Welcome to another draft physics presentation. Alright, so anyway, I thought I'd do another video about this response video by the Mindless Marbles guy and a couple of the troll comments on his video. So it's good somebody makes videos among this group of whatever they are, and just so I can see their comments. Because it's just the same routine of, accusations, veiled, not veiled, that aren't defendable by anything called evidence. So anyway, so he says a low quality video, I'll agree. To an inconsiderate jerk, yes, like you're something else besides an inconsiderate jerk yourself, where I do a few simple things. Yes, I did a few simple things also. He should have done long ago. So I should have put a paper cone around a flashlight to do the experiment a long time ago and used a big thick piece of glass. I should have done that a long time ago. I don't think I should have done either one of those. So again, just more pointless rags. So he does a really inadequate experiment poorly and doesn't really deal with any of the theory that is the whole thing at question, is the theory. So I'll go through what their theory is, even any explanation, and how underdone the physics is of those explanations. This whole idea of half-silvering a mirror. Half-silvering won't work, actually. Theoretically, it can't work. It has to be some other number, not half. by just logical reasoning. So anyway, so the Devo, whatever this CeeLo guy is, why are you so desperate to win Gary's approval? Question mark. So he's such a troll, he's trolling the other troll, which is funny. Do what the rest of us do and sit back and enjoy this foul-mouthed bigot. So I'm a bigot in which way? How am I bigot? What are you? I don't know. What's Devo Elo mean? I don't know. You a Mexican who doesn't believe in mufflers? Doesn't speak English? Yes, the Mexicans who don't speak English and don't believe in mufflers, I'm bigoted against, quote unquote, whatever bigoted means. Such a stupid. Yes, I don't like them. Yeah, I think they're jerks. Hey, I mean, when they come here and expect me to learn Spanish, they emigrate to the United States and expect me to learn Spanish. That's like me going to China and expect all the Chinese people to learn how to speak English. I think that would be retarded. So I call it what I see it as. And that means I'm a bigot. Is that it? Anyway, waste another 7 years of his life with this cockamamie theory. So again, it's so bad a theory, and yet he can't debunk it with a single fact. He can't point out a fact, an experiment, a real thing, to explain why my theory's cockamamie. And so he can resort to his name calling, for which he will be allowed to just do that here, in Troll Central. And then this Alexander Zaptia cunt, he says, if you read the description, you see he calls Gary inconsiderate jerk and explains he's doing basic checking. So he's doing basic checking by doing another really bad experiment. Now, I didn't claim my experiment was debunking anything beyond just pointing out how glass creates a pretty good beam splitter. That's all I was doing. That should have been done by Gary. And again, they can't undo the facts I gleaned. They can't undo what was observed fact. So, again, just more argument. Do you not know specifically the exchange? So he doesn't know. So he says, I do not know specifically the exchange between these two. So, but I'll comment anyway, because that's what trolls do. But it seems to be a disproof via experiment. So a disproof of what? He disproved nothing, because he misunderstood my claims, which were for the purpose of the experiment, that is, creating two beams, the plain piece of glass works well enough to create an interferometer that would work. It doesn't have to be 50-50 perfect. I mean, unless you have a theory why it has to be 50-50 perfect. There's no reason to believe it has to be. Anyway, that the angle away from the surface normal has to be 80 or above 50 degrees or above for 50%. So again, he takes what this guy says, and what this guy says is also a misinterpretation. It'd be 80% from one surface. 80 degrees if it's just one surface. If it's reflecting off both surfaces, then it's some other degree, lower, presumably. Light to be reflected. Is to challenge him and act of gaining approval. And right, so to challenge me again with more poorly done argumentation and distortions of what the other person is actually claiming. Straw man arguments, essentially. All right, so back to the basic ideas. The interferometer, light goes in, reflects, comes back, goes through, light goes through, comes back, and reflects. Now, if you understood these as two paths, so, you know, we'll color this one. Well, I should have just colored the return paths, but it doesn't really matter. You can see that if something happens to the light on one of these paths, there's the path that goes through the splitter. So this is the end up being the one that went through the first time, and this is the one that ends up going through the second time. You could understand that the argument I'm making is pretty obvious, that if you have a surface, oh yeah, sorry, forgot, gotta turn the drawing on. That would help. Nah, there it is. Could make it bigger, Gary. Well, I'll worry about that later. Alright, so there's two paths. And the point is when it goes through the glass, it's getting diverged because it's going through a bunch of half-silvered mirror by their theory. And when it does that, the light will, by probabilistic rules, go in one of these paths. And so obviously the paths are not straight paths. Obviously a high percentage of the path will be a diverging path, an angle. And that angle will just get multiplied with distance. So the further it travels, the more the light is spreading. So it's spreading, and then when it reflects, it spreads. So one path is spreading for the entire length and back, and going through back through this, reflecting off the splitter. So one beam will be highly diverged. The other beam will only diverge this little tiny bit here. So the other beam will just be tiny bit diverged. So those are hardly equal beams. So the theory of the interferometer is you're using equal beams, that there's the two paths are in every way equal, and there's and so you can do this recombining of light or splitting of light and all this stuff, and you're working with two equal beams, so any change you see will be a reflection of some intrinsic or fundamental property. So, but clearly, boy, the mic is in the red a lot. Let's see, maybe turn something down here. Yeah, gain is here, I think. Hello? Which way do I turn it? If I turn it around this way, off is that way. So it really, yeah, that just doesn't seem intuitive. This way should be off. All right, well, yeah, that just doesn't look very good. All right, turn the mic around. Gain down. Sorry, I shouldn't change the volume in the middle of the video, but I don't like it going red. Anyway, I'm sorry, this is not one of my better videos so far, but maybe it'll get better. Alright, so there's a theoretical problem with the beam splitter. So all of this is an argument about what happens when light goes through one of these beam splitters. So we'll make the piece of glass bigger and try to understand some of this stuff. Now, there's another subject related to this subject is in the Feynman lectures, where he describes Newton's glass. And so Newton did a ton of experiments with layers of glass, with thicknesses of glass. And what he discovered is that you can change the thickness of glass. That is, you can shave a little bit off the surface, and you can change the reflective index of the glass anywhere from 0 to 16%. So you can make the glass reflect total 16% of the light, or none of the light, 0. You can make it so if you get just the right thickness, and that pattern repeats. So at every section you could repeat that same pattern. So as I make it thinner and thinner, it goes from 16 to 8 to 0 to 6 to 8 to 16 to 0 to 8 to 16. So it just repeats that same pattern over and over again. And as Feynman pointed out, they've done it with glass a meter thick, and they still have the same effect. They just polish a little tiny bit off, and they can get to 0, and then 16%, 0, 16%, you know, with the 8 in between. And so that's a feature of glass. It's very interesting. And that would also be affecting the reflective index. So that means that the angle, how much of the light reflects at a certain angle, you know, and this is what we're sort of talking about, is this angle. That angle would also create more or less reflections, you know. So maybe the slide glass I'm using has the right reflective index, that is, the glass is the right thickness, that at 45 degrees it creates a 50-50 beam splitter. So I'm just saying this is another feature of glass. Nobody accounts for it. Nobody talks about it. Nobody talks about it in relation to the creation of beam splitters. Nothing. Okay, so the point is, I would make an argument, if we're going to worry about explicit language and everything has to be so, we're going to hold everybody to everything they say, okay, the very idea of the idea of that light comes in and we say, you know, straight, and then we should expect 4% off the surface. Well, the trick is 4% of the light had reflected off, so there's only now 96% of the light left. So only 96% hits the second surface, right? So this is 96%. So it could be 4% of 96%, if you get me, right? So it's still going to be not 8, it's going to be 7 point something, because finally ran out of black. Because there's less light that gets to the second surface. So it could never be actually 8%. So that's not even precise. So it's always going to be some factor dependent on how much light actually got to the second surface. Well, it's going to dictate how much light reflects off of it, theoretically. All right. So I guess I need a new drawing. Probably wouldn't hurt. Try to do this efficiently, paper efficient or whatever. All right, so back to the piece of glass again with the mirrored surface to make my argument. So the mirrored surface, if it was 50-50, okay, 50%, 50%, that wouldn't work either for this very same reason. Because we know some of the light, especially at 45 degrees angle, some of the light is going to reflect off the first surface. So we know, as a fact, that it's going to be, it increases with the angle. So I'm just saying we know that straight in did 8%. And so angles are going to be more percentage, 16%, some other kind of number. And so we know that we're going to lose, let's say we just make it 16% for the sake of argument. So now we only have 84% getting to the second surface. So only 84% gets to the mirrored surface. So we only have 84% of the original 100%. And so what are we supposed to believe? The same 16% is going to, so now we have a 50-50 mirror. So where the mirror isn't, okay, that's going to have a 16% even without. So the little blocks that are the openings between the mirror, those are going to be 16%, the same percentage as the surface. But the ones with the mirror, we know those are going to be 100% of whatever hits them. So you can see that this mathematics gets a little complicated. I mean, it's going to be 16% that will reflect even off the empty spots. So the place where there is no mirror, the light's going to go in, and 16% of it's going to reflect off even though there's no mirror there. And 100% of the light that gets to the second surface, that is 100% of the 84% that hits a spot that has mirror, that's going to reflect. And so only 84% of 50%. So now we have 50% of 84% of the light minus 16%, right? So we're 50 of the 84% and then minus another 16% that's going to reflect when it should go through. So the light going through is going to be 50% of 84, which is 42%, you know, and then 16% of the 42%, which leaves whatever, some other number. Anyway, it's going to be some fraction of this, which might only be 25%. So only 25% of the light or something is going to actually get through the mirror, and that light is going to be diffracted. So you could obviously see that a 50-50 mirror, a 50-50 coating on the mirror wouldn't work, because only 84% of the light's going to get to that surface, and then once it gets to that surface, 16% of it's still going to be reflecting off of the mirror, I mean the glass layer, and it won't go through. So clearly it can't be a 50-50 mirror. There's no logic to defend the idea that a 50-50 mirror could possibly work in that location, in that configuration. So it would have to be some other percentage, 25-75 or 40-30 or something. It would have to be some other percentage of coating versus non-coating. And again, I just reiterate, any light that goes through essentially is going through a quantum mechanical Huygens-Heisenberg space, which will cause that light to diffract and spread over permutations. Each one will pop out at a different angle, but the average will be a cone of light that is diverging. So now the light's not going to be going parallel anymore. It's going to be spreading. It's going to be traveling at a different angle than the light that reflected, which the light that reflected isn't diverging at an angle. It's angle in, angle out. On the mirror, it's angle in, angle out. There's no divergence of this beam. So this beam is all coherent light, all moving together. And this beam is all spreading light, not moving together. Blue is running out too. So this is real arguments. Now, to go one step further to complicate this, what I also observed in doing the experiment that these people ridiculed, as somehow I should have done some other experiment, was finding out that you don't need half-silvered mirror, in the sense that any dirt you get on the glass surface will create that diffraction. And depending on which way the light's going, so let's just say this is dirt or water molecules or anything separated by a distance, that what happens is when the light comes in, it refracts. So that was something I didn't point out in all of this too. The other factor you have to consider is that when this light comes in, it's angle in, angle out for the reflection, but the internal, the stuff that goes through, refracts. So it changes the angle a little bit. And so now this steeper angle means that less light will actually reflect here. So this won't be 16%, it'll be something like 15%. It'll be some kind of, well, not 16, 13% or some other percentage based on how thick the glass is and how much the refraction is. So the light always refracts. When it comes to the second reflection, it's going to be a refracted beam that'll be coming at a lesser angle, which means that the reflecting index will be different. And the only way you defeat that is if the light comes straight through, because then it doesn't refract. Supposed to not to. Supposed to not to? Yeah, supposed to not to. So this gets really complicated in terms of understanding why these things exist. I've sort of explained that the atoms have an alignment where they're in glass, where there's every likelihood that they're spaced at these geometric angles. And so when the light comes in, when you rub some of the surface off, you're changing the shape of these atoms in terms of their alignment a little bit. So as you change, you can't take a half an atom off, you can only take a full atom off. And so as you start to change the pattern of the surface, that's what's changing the reflective index. And that's happening because the atoms line up to the entire length of the glass. So what you do to the surface also changes the other surface on the other side. Both surfaces are changed by any change to either one of the surfaces, because the atoms have to realign to keep doing this odd even thing. You can sort of, it'd be better if I did that in colors, I guess. But you know, the idea is they don't line up. You know, these two line up, these two line up, then these two line up, these two line up. They have a geometry that they'll always seek. And then when you start changing one surface, you'll change the other surface because the pressure will change. Glass is technically a liquid. Alright, so anyway, back to the garbage on the surface. So what is found to be one of the functions of this optical experiment, this idea of creating a beam splitter, one of the complications of it is that, yes, if you have any irregularity on the surface at all, what happens is the light comes in, it goes through the spaces between the matter bits. It essentially creates a single slit experiment, and the light will reflect at all these angles. Now these angles can end up being very sharp angles. So this angle, for example, is it's a stronger angle than the angle coming in, and this angle would be much stronger than the angle coming in. So at the higher angles, there's a higher likelihood of internal reflection. So essentially, I can't draw it very well in this image, but the idea would be it spreads out more, but I mean a millimeter is a lot on the physics level. But the idea would be the light reflects inside the two layers. And at any one of these points, there could be a 4% chance that the light goes out. So at this layer or this layer, there's a 4% chance each time it hits that the light would go out here. And then if it keeps bouncing, it could go out here. So it could go out at any one of these locations. Now, clearly what you could sort of understand by those internal reflections is that is very reminiscent of the ring pattern. So it gives you a perfectly rational and reasonable explanation for why the pattern in the interferometer is a bunch of concentric rings inside of each other, is because these are the internal, these are just a reflection of light that got further and further. So this light only reflected twice, and then this light reflected 4 times, and this reflected 8 times inside the glass, and this one 16, this one 32, whatever the numbers would be. But yes, the further out the band is, the more internal reflections it survived. The probabilities, like rolling dice, it didn't roll craps. You know, it didn't roll snake eyes. So you say only when you roll snake eyes do you pop out. So you could sort of understand that you rolled a lot of dice and it didn't roll snake eyes, so it ended up way out here. And then, you know, with each one it just means that, yes, this guy happened to roll the dice and he got snake eyes the first time and he's out. So there would always be more energy in the inside. There'd be more intensity because by the time you get out here, there's fewer permutations. Fewer dice survive. Dice rollers survive to do their 30-second roll. Okay, or their 40-second or their 50-second. So as soon as you roll snake eyes, you can't roll the dice anymore. So obviously these rings would be much brighter, and these rings would be much dimmer because there's fewer permutations out here. The odds aren't any different. It's just that there's fewer people still rolling dice. So there's obviously fewer chances to create a photon in that location. So anyway, this is the complexity of the experiment. This is the real stuff that has to be talked about and understood to understand what a beam splitter does. And these mockers and ridiculers, that's all they are. They're just mocking and ridiculing the fact that I'm pointing out how this experiment is really complicated, and they're trying to make it into some kind of simple thing where you just half silver a mirror and you have two 50-50 beams. And that's obviously not what takes place. It's obviously more complicated than that. There's obviously a lot more physical phenomenon going on. So now let's just get to the fact that we're not given any consistent argument for what's happening here consistent with their theory of quantum mechanics. So somewhere in here if I state it as a fact that there's no, so let's see if they have a counter argument. There's no evidence and there's no theoretical argument made that different photons, two different photons, can create a wave function or do anything, and the different photons can interfere with each other and create an interference pattern. Quantum mechanics basically says a single photon hits an obstruction or some kind of object that causes it to break into two wave functions. Those two wave functions can do separate things and then they can recombine into a photon that lands in a location. But there's no argument that these wave functions are ghost tons, okay, that are going to somehow get out of phase, you know, do something to get out of phase, and then interfere, and then end up in a different location because their phase is different. Well, it doesn't even make sense. When you try to make it make sense, you can't make it make sense. So somewhere in this argument for this interferometer, they have to explain where the wave function, where the photon splits into two, where it becomes two objects that can have different destinies. And they never really explain that. Now, the presumption is, I could assume, that what they're arguing is that when the photons actually hit the beam splitter the first time, that's when they're creating this split, that a single photon goes in and it goes both directions, like going through both the slits in the two slit experiment, that somehow a representation of the photon reflects and some other piece of the photon actually still goes through. So it's one photon, it goes, one piece of it reflects and one piece of it goes through. So one photon is now 1/2 of a photon, whatever it is. It's its wave function. and that these wave functions travel the length of the experiment, reflect off the mirror. Maybe we can do the reflections in red, I don't know. I'll do them in blue. Black isn't working, so they come back, and then they're these halves, and then the halves are recombined somewhere here, maybe not here. Now the halves go, so this half goes through, this half reflects, so these are still half beams, and that somehow these half beams are now two waves, and these two waves create wave interference and decide where to end up over here. So they could end up in a different location depending on how these two waves interfere with each other as they travel this distance to the target. So that's their explanation for the pattern of rings, circles. Now the circles don't have the same appearance as the locations of the bars. In the interferometer experiment, they're not spaced anything like the two slit experiment. They're basically, the rings get tighter and tighter on the outside. They get closer and closer together. So it's a very different pattern than the double slit pattern, which is pretty much equally spaced. It isn't the same. Like if I made this into circles, this pattern wouldn't look like this pattern. They're evenly spaced circles. Sort of see that. So there's one reason not to believe this theory. Clearly, we still see that these are whole photons. If I put a mirror here and deflect this beam into my eye, these are still whole photons. They're not half photons. So, they're not a wave function of some kind. They're really, even without this half, I can make this half into a real photon. So it seems like real photons are going through here. There isn't some kind of half thing or a broken thing. It's a real photon. So that's also a reason to think that doesn't make much sense. And as I've just pointed out, so they need all this theory that doesn't make any sense. I mean, when I test these beams, they don't look like half photons. They don't look like waves. They're not spreading. They're not doing anything like a wave here, like a wave function. They look like real photons in every respect when they're tested. And yet we're to believe that somehow they're going to wave their way to the target. Again, it just doesn't make much sense. And what's the more reasonable theory? The more reasonable theory is, as has been proven to be true, that if you put garbage, junk, bits of spaced junk, dust, on the surface, you'll create diffraction, spreading, and you'll create high angles inside the glass that will relieve the glass at different locations. And that's a proven theory. So that's the context of these trolls' arguments. They say this is garbage, nonsense, not worth considering. These aren't facts that are at all important. We know all of these truths, and it's all been dealt with somehow, somewhere. They've figured out all this stuff. All that stuff I'm pointing out has nothing to do with it. That this dirt on the glass can't possibly be the answer, and internal reflections can't possibly be the cause. Somewhere they've proven all that, when there's absolutely no evidence in the historical record that anybody ever did that any of this was ever dealt with as an optical experiment. And that all these assumptions, all these presumptions, these declarations, the 50-50 mirroring, as I've pointed out, 50-50 mirroring can't work. It just can't. It has to be some other number, just because part of the light reflected off the first surface. So it has to be some other number than 50-50, because you already reflected some percentage off the top surface. You don't even have 100% of the light hitting the back surface, so it's not even possible. let's understand that by surface I mean the actual reflection could be off the next surface, that is the air layer on the glass. So the glass, the light reflects off the first layer, which is the glass, then it reflects off the air layer, that's the other side of the glass. You know, technically that could be what's happening. That's why, like water droplets on the ground, or let's just say the classic one where you're you know, there's a bunch of trees here, you know, and you have a reflection in the water, right? The trick to that one is there's no reflection from the second layer of the water, because the water could be 10 feet deep. So there's no reflection coming from the second layer of the water, because the water's on ground, and ground doesn't have any reflective index. So that's the reason. Now, if it was a thin layer of glass that you're doing this on, then the angle would be different, that you get to see more of this reflection. So that's where it gets complicated. So if you're viewing off water, what you're really doing is just reflecting off one surface. So here's a lake with water. You're just reflecting the light off the top surface, and that's it. You're not seeing the light reflected off this bottom surface, you know, refracted and then reflected back out here. And the same is true like water droplets on the street. The water droplet will reflect the light off the top surface, but it won't reflect the light off the grounded surface. So the angle necessary would be different depending on whether you're getting reflections off both surfaces. So how thick the medium is. That's why they call it a thin film beam splitter. They have such a thing. Because you use a thin film, you're guaranteeing two reflections that are going to be very close to the same angle, because there'll be less refraction inside the thin film. Alright, so that's probably enough. So I just wanted to add that as context. So the trolls say this is gibberish, this is incoherent garbage, this has nothing to do with physics, you know, that the brainiacs have somehow figured all this out and know this isn't the truth and this couldn't possibly be the answer, and there's absolutely no evidence that any of that ever took place. The talking heads have no clue about all this stuff. They just accept what everybody else does. They just assume 50-50 mirror, yes, it's reflecting half the light, and it's the same. Reflecting and going through the little apertures is exactly the same, when we know it's not exactly the same. It's completely different. Light diverging like this is completely different than light going straight. So, what can I say? People suck. These arguments suck. These human beings suck as human beings. Clearly, I haven't crossed any flat earth lines here at all. I'm not proposing anything bizarre or magical. I'm not claiming there to be any special magical forces. None of that's taken place. Their ridicule is completely unfounded and undeserved, inappropriate, unscientific, and profoundly ignorant. It's their ignorance that's on display. So anyway, till next time, such.